Right, so yeah, as Amber mentioned, my name is Jessica Nation, and I'm a Bathymetry data manager at NOAA's National Centers for Environmental Information and the co-located Iho Data Center for Digital Bathymetry. So in today's presentation, I would like to provide an overview of the Iho's DCDB, highlight the current data holdings in the DCDB for the Great Lakes region, and describe some of the tools available for submitting data to the archive. I'll also discuss the work that the Bathymetry team is doing to support regional, national, and global mapping campaigns by working to improve our overall data infrastructure, including data access and discovery. So starting out with the Iho DCDB. So how is NOAA involved with the DCDB? Well, the International Hydrographic Organization Data Center for Digital Bathymetry is the recognized Iho repository for all ocean bathymetric data. NOAA's National Centers for Environmental Information, also known as NCEI, which I know there's a lot of acronyms, has hosted the DCDB since 1990. Data is sent to the DCDB, where we provide long-term archive, data management, and open access. The NCEI Bathy viewer and the DCDB viewer share a database and for the most part contain a lot of the same information. The viewers are tailored for slightly different audiences, and the Iho DCDB has the capability to host bathymetry web services from around the world. Data archived at the DCDB can be used by anyone for anything, but today I'd like to highlight that they are routinely used for the production of improved and more comprehensive bathymetric maps and grids in support of both regional and global mapping projects, such as the annual update to the JEPCO grid. Here you can see the latest JEPCO grid published in June of 2022, which estimates that 23.4% of the global seafloor has now been mapped as compared to 20.6% last year. We can compare that number to the DCDB data holdings, where the estimated global seafloor coverage held in the DCDB multi-beam archive is calculated to be about 12%. This 12% equates to roughly 65 terabytes of uncompressed or 30 terabytes of compressed bathymetric data. This includes over 3,500 multi-beam bathymetry surveys, which are shown here in green track lines. Zooming into the Great Lakes region, you won't see any neon green track lines. Unfortunately, at this time, there are no multi-beam surveys in the DCDB archive for this region. As the panel before lunch discussed, there are challenges involved with mapping and disseminating data from the Great Lakes, which translates to a large gap in data coverage on the map viewer. However, it is worth noting the NOAA hydrographic surveys in the area. The majority of these surveys are quite old, dating back several decades, many even before 1950. Selecting the surveys with bathymetric attributed grids or bags option filters the more modern surveys, which you can see are pretty scarce. But in more exciting news, and as you've heard from the presentations this morning, the NOAA ship Thomas Jefferson has spent its 2022 field season in the Great Lakes. So we can anticipate these data being discoverable and accessible via our map viewer in the next year or two. The archive includes approximately 5,700 single beam surveys as well. But again, not a large number here in the Great Lakes. Currently, we hold 6 surveys in the region, which are dating between 1964 to 1986. The archive also includes crowdsourced bathymetry data, which is also known as CSV data. CSV is the collection and contribution of depth measurements from vessels using standard navigation instruments while engaged in routine maritime operations, so not systematic surveying. This past year, we've been extremely excited to see CSV contributions increasing in this region, like the orange track lines in Lake Erie and Lake Ontario, which were submitted by GLOS this past summer. The DCDB data viewer also shows the spatial extent of data archived to other repositories via the ingest of their web services. New web services are being added every year, but the Canadian Hydrographic Service features shown here have been on the site for a while. Here I've selected the CHS NONA 100, which displays a complete inventory of bathymetric sources required by the CHS, combined at a resolution of approximately 100 meters. Clicking on the question mark symbol next to the NONA 100 option will link the user to the CHS non-navigational bathymetry data webpage, where they can access the data. And I'm really excited to hear about what the CHS has been up to when we hear from Christine after this presentation. So combining all those layers, we get this image, the current Great Lakes data holdings in the DCDB. All Iho Dcdb and NOAA NCEI data shown on the data viewer are available for download using the identify tools in the upper right corner there. Since my team covered it last year, I won't be demonstrating how to request data through the viewer today, but if you are interested in learning more about downloading data, please reach out to me during the conference or send me an email and I'd be happy to work with you. Okay, and that brings me to my next topic, contributing data to the DCDB. So now that we've covered the DCDB data holdings, you might be thinking, hey, I might know of some bathy data in the Great Lakes that we could make available, and it would be pretty cool to be the first green track line on the map. Or maybe that's wishful thinking on my part. But if you are curious about submitting data to the DCDB archive, then you've come to the right place. The DCDB archives data from NOAA and other federal agencies. Additionally, we regularly receive submissions from UNOL's Rolling Vector Repository, which provides data from the US university fleet. We also archive data from a growing number of commercial companies, such as Fugro Geoservices, and data from international partners like GeoMar and the Geological Survey of Ireland, just to name a few. As I mentioned earlier, we are very excited to add GLOSS as well as Orange Forest Marine to this list, which are our newest crowdsourced bathy contributors. So if you would like to add your organization to this list, here's how to get started. Going back to the Iho website, at the top of the page here is the Contribute Data tab that has great information to get you started with data submissions. We work closely with data providers to ensure that their data is in the best format for public use, the metadata is descriptive and informative, and to determine the best way to get those data to the data viewer. Our website provides information on acceptable data formats and resources to assist in the packaging and submission of data. At the top of the page, you can see a link to our guidance document on submitting marine geophysical data to the Iho Dcdb. This document describes our recommended procedures for preparing bathymetry and other marine geophysical data sets for submission, including guidelines on data formats, metadata information, and directory structure. Understanding that organizing data can be cumbersome, the DCDB website also provides resources to assist in the packaging and submission of data. We offer CruisePack, which is a standalone data packager tool designed to simplify the process for data providers through the use of a simple user interface with pull-down menus. The software generates necessary metadata files and creates straightforward and consistent data packages. You can find the software and more information at this link that's kind of been cut off here, but it's at the bottom of this slide. And the DCDB webpage also contains information on contributing CSV data to the archive through a network of trusted nodes, which are organizations, companies, or universities that serve as data liaisons between mariners and the DCDB. If you're interested in becoming a trusted node, we highly recommend that you visit the webpage at the URL shown on the left. And for more detailed information, review the Iho's B12 document, Guidance on Crowdsourced Bathymetry, which has recently been updated and can be found on the Iho website. As is the theme in this presentation, if you have any questions about contributing data, please feel free to reach out to our team. We are here to support you. So bringing this back to one key point is both the national and international archive for bathymetric data. We at the DCDB are in a unique position to support all levels of mapping initiatives, from regional to national to global campaigns. Over the next decade, we anticipate a huge influx of data in response to the UN Decade of Ocean Science, CBED 2030, Lakebed 2030, the Iho Crowdsourced Bathymetry Initiative, and NOMEC, the National Strategy for Mapping, Exploring, and Characterizing the US's EEZ. So how are we addressing all of this? To prepare for this new wave of data, meet the archive needs of these campaigns, and bring our data viewers and data access tools to the next level, our team has added a new member, signed submission agreements with 8 new data providers, and are currently working with several others, including the National Park Service, began migrating data into our new database schema, completed the minimum viable product of a new data ingest pipeline, deployed the first version of our new CSV data ingest pipeline, and added several new map features and services. So with the addition of our DevOps, interesting. Okay, well, there is supposed to be a slide with everybody's faces on it, but it's not showing up here right now, so you guys are going to miss out on that. But we do have the addition of our new DevOps engineer, Max Smith. Our team is now able to focus on deploying and transitioning into our new database schema and ingest pipelines while continuing to archive new data coming our way. So our current database schema is rigid, outdated, and inflexible. Understanding that bathymetric technology is constantly evolving, we needed a new system that could allow for more flexibility, supporting more complex metadata parameters such as multiple scientists, instruments, and even platforms. The schema will also eventually be shared by multiple data types within the data center, opening the door for more comprehensive map viewers in the future. We are looking forward to the deployment of our new end-to-end multi-beam archiving system. Like the panelists before lunch discussed, making the turnaround from data acquisition to public release of the data more efficient is imperative to reaching the mapping community's goals. Recognizing that need is what spurred the reinvention of our pipelines. The new pipeline will feature increased automation, which will provide more efficiency in archiving times and remove some of the chance for human error. Our error notification and handling capabilities will be more robust, and the new pipeline has been designed in conjunction with the new database schema, and it includes flexible options for future file readers and plugins, ensuring the pipeline will fit our needs well into the future. And with the very recent deployment of our new CSV pipeline, we are excited to see faster onboarding for new trusted nodes and be operating in a more reliable system. So what does this overhaul of our database schema and pipeline mean for the map viewer? Well, our incredible GIS team has been preparing to incorporate massive changes into the map viewers, including separate layers for raw and processed data, as well as a layer for products, such as grids, allowing users to select a level of data to their interest. You'll be able to show polygons that represent the swath coverage derived after data ingest. And we will also be able to select individual files within a survey, a feature that's currently found in the water column sonar data viewer. We are always looking for ways to enhance the DCDB map viewer to not only improve data access and discovery, but make the data more functional for our users as well. So with that, I'd like to go over a few recent enhancements our team has made to the DCDB data viewer and share some additional plans for the future. So this slide shows our multi-beam bathymetry mosaic image service, which we added a few years back, and is a reflection of all multi-beam data in our archive displayed as a grid. This layer is continuously updated, so once multi-beam data from the Great Lakes is submitted to the archive, we will be able to see the mosaic and therefore the extent of data coverage in the region. This past year, we incorporated the grid extract tool, which allows the user to download an extracted piece of either the multi-beam mosaic or the multi-beam mosaic hillshade. After you've specified your area of interest, the download data link will be activated and you can extract and download the data in GeoTIFF format. Our CSV-specific enhancements included continued work on the implementation of an additional option for accessing CSV data. The traditional way that we serve our data to the public is by offering just the actual flat files. How the data comes in is how it goes out. So we've been working on storing a copy of the CSV data as points in a cloud-hosted scalable point store. Moving to a point store in the cloud allows users to generate bathymetric grids of a given area, facilitates use for on-prem and cloud-native processing, retrieve data density information using user-specified resolution, query the data collection for statistics, and better support the guiding of future data collection efforts. These features not only broaden data access to a wider range of users, but also support the goals of our mapping initiative partners. We are also working to expand the CSV point store effort to include our multi-beam data holdings as well. I do want to point out the text in red on the screen. This is a pilot project at this time. So there's a lot of work on deck for this year as well. The current version of the web application AutoGrid, which has actually been around for a long time, creates user-specified grids from the flat files in our DCDB multi-beam archive. Taking the work that's been piloted for CSV, the new AutoGrid 2.0 will run in the cloud and include both multi-beam and CSV point data. The plan is that in the future, the point store will also include single beam and possibly LiDAR. All right, so although these updates are really exciting and demonstrate the hard work that's been done over the last several years, we know we still have a long way to go before all of our upcoming developments are fully operational and running smoothly. But with the support of new team members, our GIS group, developer teams, and other data managers, we are very hopeful that we'll be able to meet the needs of the seafloor mapping community over the next decade and satisfy the goal, map once and use many times. So we want you to know that we are here to help. Please reach out to us to discuss how we can support you contributing your data and our map services. We also want to help you find data. And we want to hear from you all on how we can better support Lakebed 2030. And with that, thank you for your time and attention, and a special thanks to Northwestern Michigan College for creating this opportunity for all of us to come together here today. And yeah, I'm open to taking any questions if you have them.
How many users access this database on a monthly basis? I don't know if you can pick the information, but how many people are actually hitting this database and downloading data?
That is a great question. Not a number that I know off the top of my head. We currently have a software that gives us those stats, but it has been broken for a couple months, so it's just now getting fixed. It's called Cabana. We're just now getting fixed, and hopefully we'll be able to start getting those stats pretty soon. But yeah, unfortunately, I don't have the number off the top of my head right now.
We've asked for those stats for NOAA data in the past, and it can be in the hundreds per month, depending on the types of data. I mean, we try to look at what products, because in addition to raw data, we have like a GeoPDF and some other things, and we're looking to see what's the most downloaded. So I don't know across the entire database, but I can say when we've looked at it in the past, it is a significant number. I think some folks might be auto downloading to see what the updates are.
Yeah, I guess I could say like a ballpark guess. We've had before the software shut down, we had a couple months where it was like thousands of people pulling down data, and that's not just people that are looking at it, they're like actually downloading the data. I think we had one month where it was around 9,500, but again, we kind of talked to our NOS guy at the time, and he mentioned that it could be a bot that's just systematically pulling data. So it's hard to know like how many actual real life customers there are, but yeah, the bots have been pulling down data more recently. We've seen that kind of uptick.
I'm assuming you have some security set to that.
For the web page, I don't believe so. All the data on here is just publicly accessible, so anyone can download it, whatever format they like. I know a lot of people are interested in using APIs to programmatically pull down the data. And that's something that we are looking to work on with this new pipeline being in the cloud. We're trying to implement that as well, but that's not a current functionality.
Yeah, I originally raised my hand to just give you kudos because I realized that some of this is the less glamorous, exciting part of this. Right? Everyone wants to go out and use the cool equipment and acquiring data is relatively easy and fun, but the processing and then putting it into a format that's easily disseminatable and all of that is non-trivial and challenging. So I just want to say thank you to you and your team for doing those things.
Oh, thank you.
Because I think the more easier it is to access, the more likely people will use it and we'll start having more of that contribution as it like goes. And I know it's not a minor undertaking to redo the data architecture, but I know as a user of NOAA, we're excited that that's happening. So.
Great. Yeah, we love hearing feedback like that from our users. And so if anyone does have experience with using the Bathy viewer or the new features that I mentioned, like grid extract, multi-view mosaic, yeah, we love getting feedback about that because sometimes it's difficult to guess like where our users could most benefit. So hearing what users are looking for is super helpful for our GIS teams to know like what's the next thing we can do with the map viewers. So thank you.
Any other questions?
Is it an Esri backend that it's built on?
Yes. Yeah. So there's different base maps that you can filter at the DCDB. So I think the one that it's turned on to is a Jebco base map when you just immediately go to the web page, but you can filter out the base maps. Some of those image services that I was mentioning, the multi-beam mosaic, those can actually be downloaded in a tiled package. So for folks that want to use them offshore, our GIS team can provide those to users.